And this way we could say that we were done at this point if we liked. However, a lot of users prefer to have a two-stage boundary layer where they would have a more refined boundary layer around the airfoil. Zoom in, split block, add an edge. The method is screen select, so you can grab it and drag it. And you can put it to whatever size you would like it to be. Let's go somewhere around about there. So let's set a new distribution within that boundary layer region. We'll select this edge. Currently there's 5 nodes. We'll put that to 15. 0.5 is still good. Apply. And let's match edges heading outward also. So match edge tool. So select this edge as the reference, this edge as the target, and that matches edges in that direction. We could do these all the way around, or we could select this edge out here and copy to parallel and apply. And this gives us a nice two-stage transition. So we could use match edges in other ways also to improve our distributions. Maybe we'll want to match between this edge. So now we have a mesh that's technically matched, but let's try some smoothing to get it improved. To smooth this model, let's convert it to unstructured mesh and go to the Edit Mesh tab and Smooth. So you can set the number of iterations and grid expansion rate and all these various settings, how you want it to work. I'm going to go with orthogonality. I'm not going to freeze any surfaces, but I am going to want to fix that initial height down there. So let's select the curves, and instead of releasing orthogonality, I'm going to set the initial height to 0.005. Everything else we're going to leave as is, and apply. And after 10 iterations, you can see that it has moved off its original locations. Let's turn off that pre-mesh so we don't confuse what we're looking at. And you can see it's more orthogonal. Now you don't have to stop here. You could run this a bunch of times, and every time you run it, it'll get a little smoother. At some point, your model will be smooth enough, and it'll be time to output. We select Output, select Solver. A variety of solvers to choose from in here. We're going to go with Fluent. Apply. The boundary conditions in ICEM CFD are based on the family names, so they're family boundary conditions. And so you would go in here and find the ones that you wanted. So for instance, the far field would be a pressure far field, and perhaps the curves, which are the airfoil, would be your wall boundary condition. Wall is actually the default, so you don't need to enter it. You've got a fluid here, which is your fluid part, and so on. So you could go through it and do that sort of setup. Then you say accept. We'll save our current project. Say this is our airfoil file, and we would name our Fluent file. So Fluent 2D airfoil. So now it's output to Fluent. Let's take a look at what we have here in the replay script. Now let's clean this file and renumber. So we got rid of over 100 lines just doing that. You can also edit explicitly. We can go into Edit, and I can look for commands I don't want, such as create mesh lines. And if I delete a line like this, it just means that that line wouldn't be reproduced when it runs through it later. Since for large models, create mesh can take a long time, I might add this to the filter even and remove it that way. All these delete node items here, I can get rid of these. They're not really important. Let's save this replay control window. Now here's where the power of replay comes in. So let's go and unload this model. Okay, so now we're starting fresh. What we can do is go in here and edit this file to change this NACA profile. So instead of 4412, we'll use one of the other ones I have in here, 6614, for instance. File save. We'll turn on the always update option to do all. And it goes in and it imports that geometry just like last time, except it's a different airfoil this time. Goes through all our steps, create geometry. Just turn off these surfaces here. You can see it fitting to the geometry, collapse this back block. Even repeats the smoothing for us. And outputs another Fluent file. And we could go back through and say, alright, let's do the same with our next one. File, new project. Just don't save anything. This time, let's edit this. Put in a different number. 8306. And we could do this with a variable instead if we wanted to. Do all here. And if you don't want to wait for it to update visibly, you just turn off the Always Update button, and it'll go much faster. And there you go, again, another mesh output to the solver, all off that same script. Thank you very much.